you can use this. Okay. But at that time, you have to remove this diameter narrowing. Now you can see that there is no error. If you use both, then you find there is an error. There are error, the model is not constructed. At a one time, you can take only one variable. Okay. So in this way, you can get the accuracy. You can see that this, when I am taking the another variable, target variable, the accuracy and the values are changed very fast. Okay. Okay. So you have to do error and trial to achieve your accuracy. What accuracy you want according to your data set. Okay. You can also change the number of iterations. Okay. Now you can also draw a confusion matrix. So for the confusion matrix, you can put here a widget that is a confusion matrix. And on the basis of that, you get the confusion matrix. That is a 0, 1, that are the target columns. And these are the actual, these are the predicted. And on the basis of that, it decide that what are how to calculate the evaluation parameter. Because all parameters, evaluation parameter, either it's the accuracy, precision, recalls, or are based on the confusion matrix only. Okay. You can also draw a one chart that is mostly used for the concluding the results graphically. That is a ROC curve. Okay. So you can also draw ROC curve. Here you can find that there is an error. So can't output a model. Please, if you finding any error, then you can check. Okay. So for that, and I have to connect this confusion matrix with ROC curve. Yes, actually, it is compulsory to connect because for testing, it requires both the things, model and the data. Because for testing, it required a data set, original data set for the testing. In the select column, we are using 30-70% data set for building the model, and the rest of the data set we can use for the testing. Okay. You can also do a one thing. You can in the data sampler, you can make a two data. One is for testing and one is for training. And after that, you can also do this. For example, I explain you. For example, here you get the 70% data. Okay. Now you can take one more data table. Okay. Connect with this and Let's 1 minute. Okay, here I am using only 30%, for example. Okay, so in this data table 2, you can find 213 instances are there, but in data table 3, you are finding 94 instances are there. Okay, now you can use also select column here. And I am making this fasting blood sugar here, because for the testing and training, the same target column is required. Okay. And now I am not connecting this select column with this test underscore. I am connecting with this. Okay. So what is that meaning? 70% data that are random sampled are used for the building a model, and rest 30 data used.
So, hello, madam, you are just muted. Yes, she's just muted. Please wait, she will, yeah, she will come back soon.
Hello.
Yes, madam, please.
Yes, sorry. Yeah. So basically, in this way, you can make a separate data set for training and testing. So these different methods are available. Either you can randomly sample in a one way and use say the same data for training and testing, and there is another option available that you make a separate data and that is used for the testing. It totally depends on you. It totally depends on your objectives, that how many data set you required and how much accuracy you required, and according to that you can use data sets. Okay, so this is also a way. Understand? Okay, now I am going to use this ROC curve. Okay, so you can find this evaluation result. Actually, when we are classifying, when we are applying this model, okay, in this model, we already select that if we reach the 95% accuracy, then and only the classification stops. Okay, so depending on your objective, how much accuracy or how much precision you want for your model, you can set here. Okay, and it, depending on your accuracy, it gives, it's build a model. So I think means it is a means first you decide the target, what is your target, and after that the model is built. So there is no chances that you cannot get your accuracy. But yes, if you don't get the other values like this F1 score, area under the curve, in that case you have to do the error and trial. Actually, in any research, we first fix that what results we want. Okay. For example, in the medical field, mostly when there is a testing of any uh, tablet or testing of any vaccines are there, in that case, company claims that with the accuracy of this vaccine is this much percent. Okay, but for example, in the vaccine, if anyone say that the accuracy is a 70%, then you also know that no one can take that vaccine. So first they fixed that how much accuracy they want to for believe or to for getting the good response from the users, and after that they are doing the manipulation in the data set, in the sampling form, in the clustering form, and to achieve that accuracy. Okay, and mostly if the area of under the curve is less than 0.5, it means that the model is not good, not good. So in that case, you have to means change the training and testing proportions and all that to achieve the accuracy. Okay, so for example, here I am not getting the accuracy. So in that case, it might be possible uh, if I use the more samples. For example, if I increase the sample size here, okay, and I take a 86% data for building the model, and for testing, I am using only, for example, 24% of data. Okay, in that case, the results changed. Okay, so again, you can see that the AUC is somehow some percent increase, but not as per our requirement. So in that cases, you have to training size, you have to increase, for example, then you get changes in the AUC values. You can also do the samplings. In that case, you find that the AUC is decreased. So it means that the sampling is less required sampling. And if you are repeat the training and testing uh, for 2 times only, that you get the AUC value is higher. So this is just error and trial process. Means it might be possible for some data you get a accuracy in first attempt, but it might be possible in other data set you require a lots of efforts to achieve the accuracy you want. Okay, understand? So this is a first algorithm, that is a decision tree algorithm that is used for the classification. In decision tree, it is good that we can visualize the result in the form of the tree. Other algorithms like naive-based algorithm, we don't have the option to visualize the result. We have to only believe on the values that we get. Okay. So now I am taking a new data set to apply the next algorithm, that is a naive-based classifier. Okay. These all algorithms are classification algorithms, CNN, KNN, random forest, gradient boosting, SVM, linear regression, logistic regression, all the ADA boost, all these algorithms are the classification algorithms. And all these algorithms are also used for the machine learning purpose. These coding, you can customize the coding if you have knowledge of the coding, and if you don't have the knowledge of the coding, you can directly use Orange to get the results. Okay. So now I am taking a new data set. I think there is a possibility to get the code of this. There is a one thing that is a Python script. Okay. Actually, this is a you have to create a Python script and run. You can run here. Actually, I found somewhere in the internet that yes, we can download the Python script of this visualization also. But Orange is also available in the licensed version. So lots of the functionalities are not available with the free versions. So if you have the licensed version, it might be possible that you can do or download the code also. Okay, so now I am going to start the new data set and apply the naive-based classifier. Okay, so I am opening this new workspace. Okay, so now I will show you the PPT, not a problem. Okay, yeah. So now I am taking a new data set, and that is my primary data set. So I am taking the CSV file import. Okay. Now I am taking my data set, like for example, this wine quality data set. Okay. I am sharing you this data set in the chat box also. You can download and load this data set. Now connect this CSV file import with the data table. And we get this data set. Okay. Please download the data set and load the data set. And when done, please message so that I can move forward. Everyone get this data set? Okay. Now please check that there is a missing values in the data set or not. Is there is any missing value? Okay. So if there is no missing value, so do we require pre-processing? So we don't require pre-processing. So in that case, we directly use the sampling. Okay. So in that case, I directly use the data set is already available in the chat. I again share you, not a problem. Okay. Now I have to sample the data set. Okay. So I take a data sampler, connect with data table with the data sampler, and in the data sampler, I am this time I am not using the fixed proportion. I am using the fixed sample size. Okay. And in the data table, we found that how many instances are there? 1599 means near about 1600 data sets are there. So for example, I am taking 1000 from 1600. So I take a 1000 instances. Okay. And sample. Okay. Now I have to check that these 1000 values are sampled or not. So I connect this data sampler with the data table one. Okay. Now you can get the 1000 instances. Okay. So in this case, I am using the fixed sample size. Okay. In the first example, I am using the fixed proportion. It totally depends on you. Totally your choice. What options gives you a good result? According to that, you can take any option. Choose any option. Okay. Done. Now, the rest data. How many data? In this, there are 1599 instances. And I am only choosing the 1000. Now, how many rest are here? That is 599. So I am using another data sampler. Okay. Connect with the data. And here I am taking a fixed proportion of 599. Okay. So it means that rest of the data I want to use for the testing purpose. Now I can check that 599 data is available here or not. You can see that 599 instances are there. Okay. Yes, there is a possibility. There is a possibility because in all the cases, it is happened that the random sampling is done. So it might be possible the same row is available in the testing as well as same row is available in the training also. So if you want that the data is not repeated, in that case, you have to prepare the two different files, for one for the training and one for the testing. Okay. Okay. Now I am going to apply the next algorithm. That name is a naive-based classifier. So if you know that the naive-based classifier, naive-based is a one algorithm that is based on the conditional probability. Okay, so conditional probability means if something is happening, then what are the different things that is also happening with the event. Okay, so in that case, for example, if I am taking the example of this PPT, in this PPT, you can see that if a person is experience is greater than 5, plus a person having the post of the assistant professor, then what is the probability that tenure is yes or no? So in that case, the conditional probability statements are using. So if you learn theoretically that what is a naive-based classifier, this naive-based classifier is totally based on the conditional probability theorem. Okay. So now I am going to use this naive-based classifier. Okay. Now I have to connect this training data with the naive-based classifier. You can see that there is an error. If you find any type of error, please check that what is the error. You can find that the data has no target column. So why I put this here and show you the error? Because we already know that the naive-based is a supervised learning algorithm, and all the columns are if independent, no column is a dependent, we cannot apply the supervised learning algorithm. So for that, we have to first use the select column, and after that we can apply the naive-based classifier. Okay, so I am removing this. First, I have to use the select column. Okay. Okay. So the concept is that in the supervised learning algorithm, it is compulsory that in data set, at least one dependent or the target column must be available. If there is no target column or no dependent column, you cannot apply the supervised learning algorithm. And I made a mistake that all the data, all the columns I have taken, I am using in my algorithm. So it is not possible. There is at least one column that has a nominal value. And for that, I have to use the select columns. So in the select column, you can take any target column. But in this data set, I think there is no target column, because all data set has the numerical value. Let's I take this quality here and check that this is working or not. Otherwise, we have to convert data also. Okay. Let's first I check, then I explain it. Okay. What error we are getting?